Opaque objects will reflect certain wavelengths of visible light and absorb others. Remember that an object is opaque if no visible light transmits through it. Some light is instead reflected and some light is instead absorbed. For example, let's consider this orange fruit. If we were to direct orange-coloured light at it, then this light will be reflected. Remember that the wavelength of visible light determines its colour. So it's the wavelength of this orange light that means it will be reflected by the surface of the fruit. On the other hand, if we direct blue light at the orange fruit, it will not reflect. It will instead be absorbed. Its wavelength means that the orange surface can't reflect it, though you don't need to know why the wavelength determines this. So we have orange light being reflected off this surface, which is also orange. So is that a coincidence? The colour of the object is determined by which wavelengths from white light are most strongly reflected. Let's imagine we're directing white light at 3 different surfaces: one red, one blue, and one green. Remember that white light is formed by a combination of all wavelengths of visible light. As we saw with the orange fruit, each surface will only reflect the wavelengths of the same colour. So the red surface only reflects red light, the blue surface only reflects blue light, and the green surface only reflects green light. In these cases, the other wavelengths in the white light are absorbed. Now remember that when we see a surface, the light rays which reflect off it are being detected by our eyes. Our brains then determine where the surface is based on where these rays originate from. However, we will only see the colours of light which actually get reflected by the surface. Our brains also use this information to determine the colour of the surface. It must be the same as the type of light it has reflected. For example, because our brain knows only green light is reflecting from this surface, we see this surface as green. Often, surfaces will reflect multiple wavelengths of light at different intensities, resulting in different tones and shades. There is also a special type of surface that reflects multiple wavelengths of light. White objects will reflect all wavelengths of visible light equally. Here's an example of a white surface. When we direct white light at it, none of the wavelengths in this light will be absorbed. So the light which reflects off the surface will also be white. And then, because it's white light reaching our eyes, we see the surface as white. Also for this surface, if we only direct one colour of light at it, like red, then we'd see the surface as that colour, since that's the only colour we see reflecting off it. There's also another special type of surface you need to know about. Black objects will absorb all wavelengths of visible light. Here's an example of a black surface. When we direct white light at it, there won't be any wavelengths reflected. They are instead all absorbed, so there's no light to tell us what colour this surface is. Though in practice, there's usually a small amount of reflected light to at least tell us there's something here. Otherwise, this would just be a gap in our vision. For your exam, make sure you can explain what determines the colour of a surface, including these special cases.
Thanks for watching. If you want to take your GCSE revision to the next level, head over to launchpadlearning.com and check out our smart learning platform that's been designed to get you top results in your exams. We cover your whole specification and make revision fun with interactive quizzes, easy-to-follow videos, and more. You'll be kept motivated by your own AI tutor who's here to support you every step of the way. To check it out for yourself, click here. Or click here to keep watching a selection of the videos from our full GCSE Physics course. See you there!